So today's tutorial will be on coding style. So this is both the expectation for our milestones, all of our milestones, and maybe also for any coding that you may do during your career. So why does code style matter? Because code is written once and it will be read many times and modified many times, and often not by the original author. So the goal is to make the code to be easy to read and understand. If your code is hard to read, then the other person who is going to modify your code will be hard to modify it, be hard to understand it first. And if you are the one who is reading your code, it is likely that you have forgotten what you wrote before. So it could be a case where you cannot even understand your own code and cannot solve your own bugs. And it is challenging to reuse if you don't have code that is easily reusable, like putting them into helper functions. Then every time you need to use it, you'll be copy pasting something, which is not good. And today I will be going through the guiding principles, the aspects of coding style, the functions, variables, comments, duplicate code, group data with classes and structs, no warnings, self-checking code, and many others. So the ones that this course will be checking will be the functions, variables, comments, duplicate code. This may be optional, maybe not, depends on your TA. And we will be checking for no warnings. And the other ones are optional. Guiding principles for writing readable code is to reduce the cognitive load while trying to read and understanding your code. Because when you're reading someone's code, it will require you to remember a lot of details and understanding a lot of details. So, but human working memory is limited, which is why when we're writing the code, we want to try to minimize the number of considerations when we need to go back and read it, which is why we may need comments, we may need variables that are easily understandable, we may need names that are self-descriptive, and in your comments, in your names, you may want to explain why you're doing this way. Your code will explain how, but usually not why. And usually the original writer will understand, but sometimes we cannot ask them. For example, when I'm doing my own research work, I have this huge program that's inherited from someone before me. But when I want to make some changes because I think something is not efficient enough here, I have to ask them why they put it here, why they didn't put it somewhere else. And if I want to change it, are there something that I need to watch out for because the commenting is not sufficient? Usually I can do it, but if they just graduate and they get lots of contacts, I cannot contact them anymore, it will be hard. So first, functions, variable names, and temporaries. Google said most functions should be 40 lines or less. And that's not us, that's Google, which means this is industry standard. The long functions are hard to read, understand, and maintain. Shorter functions will force you to name parts of the code and reorganize your code if you see that the function is getting long. because functions will overgrow over time. If you have a short function at first, and every time you say, I just need to add 2 more lines, I just need to add 2 more lines, and over time your function will grow and it will become less readable. So yeah, we will need to extract new helper functions if you notice your function is getting long. Variables. So name variables with good variable names that describe the content and the purpose for the variable, so that the reader does not need to go back to the declaration or initialization to read the comments there. But you should have the comments there. Temporary scope. Having temporary variables will reduce the number of variables to be remembered when you are reading your code, because temporary variables may just be used in like a single if statement, a single for loop. If you make them like defined at the beginning of the function, you will need to remember them for the course of the function. And when you want to use them, you might need to go back to the beginning of the function to read the variable initialization, which is really inconvenient when you're trying to read the code. And yeah, and don't add temporary variables everywhere. Just add them that to help with readability and add information. Naming conventions for variables. First, start with lowercase. For variables, always start with lowercase. And you can use both underscores or camel case to name your variables, but please use the same case throughout your team. Do not mix them. If they are mixed because the underscore words are given, but you want to use camel case, that's usually fine, but depends on your TA. And constants either start with a little k or do them all caps. We usually use all caps. I have rarely seen any of the first one, but it also depends on you, and please use the same throughout your team. Type and class names. So type defines class names. Structs should start with capital. Let's look at this chunk of code. Any thoughts on the coding style? There are a lot of variables. And yeah, there are too much temporary variables. And like, just look at in general. In terms of spacing, in terms of names. There's no comments.
This is like a bad example.
It's a bad example.
Okay, yes, my foot looks like this.
Which is why we want to avoid this.
Is it like inter 1 and inter 2? Is that bad to name it that?
Yeah, inter 1 and inter 2. See, they came from info.from, info.to, and that's a loss of information in the naming. Let's do this. So first, there are no vertical white spaces. Everything's crowded together. So we want to break them into paragraphs of related code. And this is also easier to understand because we want to group related things together. So we know like this chunk is doing the same thing, this chunk is doing the same thing. There are many function scope variables at the beginning of the function that are only used in one of the if else branches. And this may introduce also potential initialization bugs because when you're writing it, you might forget what you have initialized it to. So let's just move them into the if and else. We are already getting shorter code. On the scripted variable names, int1, int2, lat long 1, lat long 2. Name loss information because we came from and to and made them into 1 and 2. And there are redundant temporary variables, as we just said. So use descriptive variable names, avoid temporaries that do not improve clarity. So we first rename the ID into street seg ID because that's ID of street segments. Don't use ID alone because we don't know what that ID is for. Rename the info into seg info because that's info for street segment. We remove the int1, int2 and put the from and to directly into the functions. We rename the lat longs to position from, position to. And we can remove the last length and directly return from the function. And let's see, we have 2 temporary variables left here. Do we still want to remove them? If we put them directly into the function, it will look like this. But this is not necessary. Yes, the previous one is clearer, so leave them back for clarity. So we came from before to after. Okay, even after we added the vertical spacing, it's still shorter than previous. Comments. Before I move on to comments, any questions on what we just saw? Okay. If we just look at the file that we gave you, in the header files, at the beginning, we have large chunks of comments explaining what this file is on, how to use this file. And at the beginning of the function declarations in the header file, the function headers, we have a few lines of comments explaining what this function is about, how to use it. At the beginning of structs or class declarations, there are also big chunks of comments explaining what this struct is, how to use it, and what does it contain. And within the structs for every field, we have 1 to 2 lines of comments explaining what this is. Then in your code blocks, before every chunk of code, we have 1 to 2 lines explaining what this chunk of code does. Which of these are the most important? Any guess? Well, most of these are important. Let's see, which one is the least important? Yes. So the high level comments are the most important, and the importance will drop by level. So first, it's really important to have the documentation in the comments. Usually people will want to put a separate document that has the documentation of the code, but this is hard to maintain because when someone just edits a code, they will be lazy or they will forget to update the document as well. But if your documentation are in the comments, the person will most likely also modify the comments. The most important comments will give the big picture, like the why. Like, why do we want to put this big data structure this way? Why do we need this header file? Where to comment? First, the most important, top of files. At the top of each file you have, if the comments are not there, try to add them, explaining what this file is about. And this will describe the biggest picture of the file. Before the data class and data structure definitions, this helps us to understand the data. And in most cases, understanding the data means understanding the code. Understand the data, why are you putting them into these data structures? And what these data structures contain. Declaration of functions. Before the declaration of functions, explaining what this function does, how to call this function. And in front of tricky code. But we want you to try to rewrite them so that the code themselves are clear enough. If the code, you cannot make it clearer, just put it in a comment at the beginning. Yes. And do not leave commented out code in your project. If you need to keep a record of your code, all of your code history are stored on Git. You can just go back to your previous commit to see your old code. And if you need to use it, just make sure when you are submitting, don't have them. Try to clean up your code before submission. And do not translate clear code to English. If you have long chunks of code, try to comment them. But if your code is already clear enough, then if you're just doing the translation, it's more reading work. So try to avoid that. And the importance is ordered from the most important to the least important. Okay. Any questions on comments? Okay, let's look at duplicate code. We want to avoid duplicate code because they can be extracted into their own functions to be used multiple times. And it was likely copy-pasted by the programmer. And if your source of the copy-paste has a bug, you are copy-pasting the bug. And if your source is modified and the bug was fixed, you have to go to every single instance of the copy-pasted code to fix the bug. And if you miss one, the bug will be there and it is hard to find. So for example, this chunk of code, this is in a for loop. And you have two parts that are almost identical. The only difference are the .from and .to here. So we would like to extract them into a function so that we don't repeat the code. So we extract them into functions and just call them with from and to and the SSID. Then, how about the comment? Yeah. Because the comments are a bit wordy because they are long and they are repetitive. So make them into a single comment for 2 lines. And make your comments higher level. Okay, next I will be showing you a demo. So this demo will be about how your IDEs can help you refactor code. I will show you once with VS Code and once with NetBeans. So let's look at the code that we have. We have the intersection street segments global variable. And we have the load map that loads in that global variable. And nothing else. We have the find street segments of intersection function implemented and everything else are empty. You will make and call EC297 exercise 1. Because everything else is empty, I'll just run the tester for the functionality of intersection. And we are passing one of the intersection tests, means that the implementation is correct. And let's look at the style of these two. Any comments on the style?
Comment also has a word.
Yeah. So it has a lot of problems, like the indentations here are wrong, right? And in the load map, we have bad variable names. Let's try to rename them. None should be number of intersections. So in VS Code, right click and select rename symbol, num intersection. And this will rename the num. And we can see that there are other nums in here and they are not touched. Okay. Yeah, there are something like X that means nothing. Let's also rename them. rename the symbol X to, this is num_sec for intersection. So this is renamed, and let's do it more explicitly. Let's just rename the I and J as well. I is the intersection. And there's another way of renaming in VS Code. So if you have a cursor on one of the words, do Control D will select the whole word, and do a Control Shift L will select all of these words, and then you can just do just in this code. It will, you can try to see if it selects everything, but for this case, because we only have this code, it will select everything, and you can just rename it to, for example, segments of I. So that's renaming. Next, I want to fix the indentation and the formatting of this function. Still right click, format selection. And VS Code is slow in terms of formatting, so you might want to wait if your machine is loaded. They are being smart about it, but they can be really, really slow. The Control D thing is much faster because you're mostly doing it manually. Okay, it's getting really slow, but I promise it worked. So let's say it worked because I don't want to wait for it now. Another problem with this code is your load map may get really, really long because you're loading a lot of data structures. So for each data structure you're loading in, make them into helper functions. But this functionality, I think it exists in VS Code, but we cannot make it work. So if you're an expert of VS Code, you can try it. But sometimes you may want to just do it manually. And yeah, that's it for VS Code. Let me revert the file and let's do it on NetBeans. Do the same thing on NetBeans. So we go to the same file, load map, same function. Renaming. Similarly, right-click, refactor, and rename. This is num_intersection. And done. X, refactor, rename X to num_section. So the renaming works as well. It is not as smart as VS Code sometimes, but if it's not smart enough, do it after reformatting and it will do the right things. And see, NetBeans is a lot faster than VS Code. It's maybe not as smart in some cases, but it's a choice. And everything you can do them manually as well if you don't want to use it. And the last thing is to make this into a helper function. VS Code doesn't do it, but NetBeans actually does. I just do it again slower. Refactor and introduce function. So in this case, it will ask for the function name. I will say load intersections 3 segments. And it returns void and it doesn't take any parameters. Refactor. It will make the chunk of code into a new helper function. And obviously you will need to add in comments and any vertical spacing that may be required. But yeah. And let's go back to the terminal. Close this. Make it. And we're having a warning because we don't have the header, function header anywhere, but I'll just skip that for now. And the test is still passing. So we have not altered the code in any way except for changing its format. Any questions? If not, we can continue. We can have a break and we can resume at 4. Yeah.
Coordinate two.
Sometimes that is okay, but just make sure that it's not. So the next thing we're going to talk about is magic numbers. And magic numbers is actually a really huge source of point deduction that I've seen from past years. Because people want to use magic numbers for some reason, even if I'm deducting mark for magic numbers every time, and they're still using them. So let's see this chunk of code. Yeah, those are magic numbers. And the 20 is also magic number. First, the 20 is a magic number that is really, we don't want to bear with that, because if you change the array size at some point, you must find and change all of the 20s in the code. And returning magic numbers -1, 0, and 1. So in this case, you must read through the code carefully to see what each one of those mean. Like -1, if you read through the code, you see that it is returning -1 whenever it sees a value that's less than 0. So which means -1 will mean there exists some minus numbers, negative numbers. And same thing for 0. Returning 0 because if there is 1 0 in the weights. And it will only return the first one that it sees. Like if you see a -1 before a 0, it will return -1. If you see a 0 before a -1, it will return a 0. But that's the code's problem. It's not a style problem. So now we can change them into named constants. And there are 3 options of making constants. First one, making it into a constant variable. And this constant variable can be defined at runtime. Another option is to make a preprocessor constant using define. So this is at compile time. But like to this course, these two will make no difference. The preprocessor one may be faster performance-wise. Or if there are things that can be grouped together, we can make them into an enum, like this. So for enums, you can either assign them a value, like 0, -1, 0, and 1, or you can just have the names there and the processor will assign them a number. It will be integers. And then we just replace all of the 20s with non-weights. Replace the -1 with has neg, and has 0 with has 0, and all positive to be all pos. Okay. And then we can change the return value from int to the enum, wt return. And this will also, in the code, it will check for any possibilities of returning out of range. And any questions on constants and magic numbers? I think that should be clear enough. Okay. Do a second demo on warnings. Exit this one and go into warning demo. This is going to be the same program that I just showed. It's the same program, and it's called in the main with this array of weights. And because it starts with a -1, we are expecting the function to return a -1. And now let's disable the warning in Makefile. So the way to disable the warning is to disable the -wall flag. This will disable all the compiler warnings during compilation. I am just showing you that I'm disabling. I don't want to see the warnings. I want the compiler to only tell me about any compile errors. And let's do this. So it's successfully compiled without any errors. And let's run the program. We are expecting the program to return -1, to print out -1. But we are seeing 1. Which means that there is a bug in the program. Can we find any bug in the program by looking at it? We're printing the return value from the function, meaning that we're not printing anything else. In the function, well, the logic makes sense. So where's the problem? Where's the problem? Why is it returning a 1? Can you actually find it? We're expecting a -1, right? Because we have a -1 at the beginning. All of the integers are signed. Yeah.
Oh, really?
You found the bug. And let's go to the makefile and let's enable the compilation. I can see it. Go to the warnings. In the compiler flags, worm flags. Notice this will enable all of the compilation warnings. And let's make clean and make. It will give the actual line that is. Because this works. If you do this, it will assign 0 to weights I. And it will return, and it will be a 1 in the if. Or a 0 in the if. So it will not segfault. It may return anything, but it will not segfault. And which is why we can go back to the program and change this to equal. And if you read the warning, it's not saying anything about we're using the wrong sign. It's just saying it suggests parentheses around the assignment. Do the make. -1. Yeah. So that's warnings. Try to have no warnings in your code. And warnings means compilation warnings. Sometimes warnings will flag potentially problematic code. And usually most of them are like you don't need to care about them because it won't affect anything in your program. But there may be some that actually does. And if you leave some warnings in, you will be hard to see the new ones. And you will be hard to see the actual ones that matter. So fix any warning right away. Stay at 0 warnings. And the flag compile flag that tells the compiler to generate all warnings is -w all. This means all warnings, and in our makefile we turn on all of the warnings. So you don't need to do anything to turn them on, but just try to stay at no warnings. And this is also a source of mark deduction. So next, group related data into classes. This may be less important because some TAs might not check it. And usually if you can explain why you are putting the data this way, it's fine. But putting them into classes is a good practice because like these two chunks of code actually do the same thing. But if you set data related to segments into a class, you can just use one vector with one vector name. And in this case, you need to give names to 4 vectors. And this just reduces name pollution because you just need to remember one name and then the 4 fields within each of the elements. Vector. This is a vector of the class. Is this clear? Go to the next one. I'm doing it really fast, so if something is not clear, let me know. Last part, defensive coding. This is the thing that we want you to have, and your testers will not check for it. Your TA might check for it, but it's actually mostly optional because you are deciding where to put in your defensive coding in. The first one is to use assertions. So within your function, use assertions to make sure that you are calling it with a valid ID and make sure that your assumptions are satisfied. For example, if we have this, we want to make sure that we're using a right ID, like not an ID that's out of range. And we want to make sure that this global variable has already been loaded, which is why we add in this assert. So to use asserts, you have to first include the assert.hc library, and then use assert. And we want to assert that the intersection ID is greater than or equal to 0. And it should be less than the number of intersections. And in this case, we are using the intersections 3 segments.size. This is also to make sure that you have loaded in the correct function. You have loaded in the correct global variable. Yeah. And if the assertion failed, it will tell you during runtime, and it will stop right there. Yes. Yes. If whatever inside here is false, the assert will end the program immediately. And it will tell you where the assertion is. It will exit the program if intersection ID is out of range or intersection 3 segments wasn't loaded. This is better than a comment because it's checked at runtime, and it will give useful error messages. And in some cases, assert might take some time to run. So when you are running the auto testers and you need the last bit of speed, just turn it off by enabling this flag. Do define and debug, and do it before the include assert. So when you are running your program on your own, you can keep in the assert by coming to this out. And when you are submitting, you can just use this so that all of the assertions will not be checked. This is for speed. Another part of defensive coding is when you are deleting something or when you are removing something. When you are deleting a pointer, if this pointer may be used afterwards, assign them to null. And afterwards, if you need to reuse it, check for if it's null. And if someone doesn't know that it has been deleted and it's used again, it will segfault immediately, which is good in this case because we don't want the error to propagate, and that will be a hard thing to debug. So set deleted invalid pointers to null. And an advanced technique is try writing self-checking code. So try writing a function to validate the data structure, whether they're correct or not. This is an advanced technique and it's not required in this course. We're just introducing it so that you know that it exists. So say if we are printing out garbage values, we should have a user search or validity checkers so that we know it beforehand. Now have the last demo, which is on assertion. Let me go back to the previous IDE demo where we have the code. And I'll open VS Code. So I'll add in the assertion, include assert.h. And inside here, we want to assert. So it will be the same code that I just showed you. Intersection ID return equal to 0 and intersection ID less than the intersections read segments dot size. Let's assert this. And we run the test again. It should not make a difference. Doesn't make a difference. Now I want to modify the tester. I will call debug tester and go to the actual test file. So I will first remove the 2 tests that are not necessary in this case. Then I want to break the assertion. Say I make this -1. And I go to the make file and compile this with unit test release, build release, and from. The assertion is triggered and it tells me where it is. Say m1.cpp line 61. m1.cpp line 61. So it tells me that this is the assertion that has been triggered. Now, we try disabling the assertion. I want to define the ndebug flag. Do it again. And from. In this case, the assertion is not triggered and we are failing the test because of the -1. And if I just revert the test file, we should be passing the test. Yeah. So this is just showing you that what I just said is true. So just in summary, keys to maintain the code is to make the code more readable because it will be read more than written. Code will be modified many times, so make small functions and avoid repeated code so that they can be modified easier. Keep the tests with the code by using assertions that are automated so they are just checked at runtime. And you don't need to run any additional tests to check for that. Keep the documentation in the code, like using comments, using clear namings of variables, and try to do code reviews with each other. So read each other's code and discuss, are there anything that's not clear enough so that you can improve? And this is also from Google. Changes should be only committed or visible until they are reviewed and approved by others. Google. Google says.
Oh, Google says that. I thought you were asking.
Because that is industry standard.
Review and improve. What if you commit everything? Like, what if you make
Usually because you are working together, so you should be the ones reviewing and approving. And if you are working in a large project with many people, usually you will be working on your own branch. And before your branch, like before you have finished with your branch, before your branch is merged into master, it will need to be reviewed and approved. Because you don't want to break the master.
it's fine to get
Yeah, leaving the assert, if you don't want them to be triggered, just use the ndebug flag. when you're running your code on your own, you can comment out that line, and yeah, it's just a comment. So the project management and code style rubric is on Quarkus, so that you can check. All of the TAs will mark with that rubric. And yeah, there are just additional resources that we have. And we have the Google style guides. Yeah, and that's it for today's tutorial.
Wait.